දැනෙන්නේ නැද්ද?
නෑ.
තාම නැද්ද? අය මොකද?
ස්කින් රෙකෝඩින් ගන්න එපාද? මේ තාම වැටෙන.
පොඩි මේකේ
හසිරිනගේ මේ වෝට් ඔෆ් ටයිම් එකෙන් පස්සේ අනුපමයියද ෆිනිෂ් කරන්නේ මේ
ඔවුනේ අය මම කියනවා අනුපමයිය තමයි දැන් කතා කරන්නේ කියලා. එතකොට අනුපමයියම ඉවර කරනවනේ නේද? technical problems. It is about creating solutions that address real-world challenges while considering sustainability, efficiency, and long-term impact. Innovation plays a key role in this process, as it allows us to transform creative ideas into practical solutions that can improve lives and contribute to society. However, innovation alone is not enough. The true value of an engineering idea lies in its ability to be developed into sustainable and scalable business. This requires combining technical knowledge with entrepreneurial thinking, ensuring that solutions are not only effective but also economically viable and impactful. Through this session, we will explore how engineering solutions can be transformed into meaningful ventures that create lasting value for both society and the future. Joining us today is our speaker, Dr. Nimantha Baranasuriya, co-founder and CEO of ThermoTune. His extensive experience in founding and scaling deep tech companies, combined with his specialized expertise in wireless networks, has made him an accomplished leader in the engineering and climate technology fields. His research has led to significant industry contributions, including collaborations with Microsoft Research, where his work was incorporated into Skype and earned multiple awards and patents. Prior to his current role, Dr. Nimantha grounded 𝐂𝐸, taking a prototype for real-time industrial monitoring to a global scale with clients in over 50 countries. He holds a PhD in computer science from the National University of Singapore and has been recognized as the most outstanding graduate of the year and a recipient of the NUS Research Scholarship. His passion for innovation is matched by his commitment to mentorship and public speaking, where he regularly shares his insights with the next generation of entrepreneurs. Followed by the presentation will be a Q&A session where you can ask questions and directly interact with Dr. Nimantha Baranasuriya to gain clarity or answers to any questions you might have. So it's over to you, sir.
Thank you so much. I hope all of you can hear me.
Yes, sir. Yeah.
Okay, perfect. I'll share my screen. Thanks a lot for the wonderful introduction. And yeah, so happy to be a part of this Tech Talk series because as like was discussed at the beginning, engineering is a core thing in the world, right? But like we need to take that and put it into use into building new products and technologies that the world can benefit from. Because as engineers, that's the best thing we can provide to the world. So we are in a good place to do that. So let's see how we can make utilize our talents and skill sets to do that, right? And leave the world a better place than what it was when we came into it. So on that topic, I'd like to talk about my entrepreneurial experiences and share some advice and experiences that I've gathered that will hopefully benefit you all as you build your own companies and technologies in the future. So before I do that, I'll give a very quick introduction to my background so that I can lay the foundation for what is about to come. So I graduated from University of Moratuwa. I specialize in computer science and engineering. So these are some pictures that were taken during my university days. You can see that the quality is not so great because back then we didn't have smartphones. Like the latest phones that we had back then were like Nokia N95 and 97 kind of like series. Probably you guys wouldn't have even seen them, right? So there were no touchscreen displays back then. It was like super early. So this is the kind of like the best quality pictures that could be taken using phones those days. But that is another example of how technology has evolved, right, in a short amount of time. So after the university, I moved on. I joined 99X as a software engineer, and then worked for the company for about 2 years. And like 99X at that point predominantly was doing outsourced software development for companies in Norway and Sweden. So most of the team, including myself, got the opportunity to visit Norway and work with Norwegian clients while we were there. So these are some pictures taken during that time. Later, after I've finished my stint at 99X, I moved to Singapore. So that's where I'm based right now. So I moved in 2011 because I got a scholarships to do my PhD in computer science at the National Institute of Singapore. So while doing my PhD, I got the opportunity to do wireless networks based research with Microsoft research, and then published my papers and even a patent as well together with Microsoft. And then, well, I was like looking for my next adventure. In 2016, I had the opportunity of either joining Microsoft as a full-time software engineer to continue the kind of work that I was doing, or at that time in Singapore, there was an entrepreneurship program, like an accelerator kind of a 6-month program that was helping technology graduates like undergrads, master students, PhD students come up with technology related companies or new startups. So I decided to join that program, and then from that program I ended up launching a new company called 𝐲𝐢𝐦𝐚. So 𝐲𝐢𝐦𝐚, if you're familiar with Harry Potter fans, there's a spell called 𝐲𝐢𝐴, which is like the summoning spell, which brings things far away from you to your hands. So both myself and my co-founder Basha, who's in this picture, we specialized in wireless networks. So we wanted to see whether we can build a wireless networks based startup for monitoring various sensors that are used in construction and mining environments, so which are called geotechnical and structural sensors. I'll show you a quick video of how this works in the next few slides. So these sensors are used a lot in construction, mining, rail, infrastructure development projects. So these are like massive projects that require digging the earth, like deep underground, and doing operations underground. So when those kind of operations happen, obviously there may be buildings, other infrastructure above ground, which should not get impacted. Like, for example, if say some miners are working deep underground mining for precious metals like gold and things like that, if the mine collapses on top of them, it's a huge disaster, right? Like people can lose their lives. So in these kind of like mission critical environments, companies monitor a lot of sensors. And at that time in 2016, when we were starting off, a lot of these sensors were monitored manually, wherein they send workers with handheld sensor readers like what I'm holding here. So the workers go around from sensor to sensor that are deployed in the environments, and then they take sensor readings to see whether something is tilting or whether something is changing. And if so, they can quickly take action before a disaster happens. So think of like, monitoring things like landslides. So those are the kind of accidents that are prevented with these sensors. So back then, as I was mentioning, most of these sensors monitored manually. So with these kind of handheld sensor readers, so we came up with this product suite that could interface with existing sensors and then wirelessly transmit the data to a cloud software through which the data can be automatically monitored. So the value addition to these companies is that they don't need to send workers underground to collect readings manually. All the data is collected in real time and displayed here. So if there are any problems, the software alerts them, sends SMSs and WhatsApp notifications and things like that, so that those accidents can be avoided. So let me show you this quick video of how it works. So essentially, like in these projects, they deploy these kind of sensors. So this is, for example, a tilt sensor that monitors whether this wall is tilting over time. Right, so that like before our technology was introduced, this cable would be literally hanging like this, and until a worker comes with a reader and then plugs in this wire into the sensor reader to see the current tilt reading. So rather than doing that, the same sensor gets plugged into our wireless battery operated devices, and then they form a wireless network between themselves and then relay the data, like transmit the data wirelessly to the gateway. And from the gateway, everything is uploaded using an internet connection to the cloud. So that was the building side. This is an example of how this works in mining. So in mines, again, many mines are working underground. The same set of sensors are monitored using our system. This is an example of how it's used in like existing infrastructure like dams. So there are cracks or like other damages in dams. Those sensors again can be monitored with our system in real time. This is another example of how it's used in rail environments. So in some countries, like again, if there's construction work or the work happening next to railway tracks, so they typically monitor the tilt of these railway tracks to make sure that the track doesn't tilt over time. So again, such sensors can be plugged into our devices for real-time monitoring. So those are some examples of how we've been deploying our technology for monitoring various kinds of sensors over the last 9 years. So since our start in 2016, we have been selling this technology in about 55 countries all across the world. So from our offices in Singapore, and this office is no longer operational, but we used to have an office in Canada as well. But we have sales team members in the US, Europe, and in Singapore that's covering all these regions. And we sell through distributors as well in some countries. So yeah, so this is what we managed to achieve over the last few years. I left 𝐲𝐸𝐻, my CEO role in 2024 to start my new startup, ThermoTune. So I haven't really spoken much about ThermoTune in this talk because it's a very new venture. So yeah, so the lessons that I wanted to share with you guys are my experiences in building 𝐲𝐸𝐻, which has been a long and a very challenging process. So before that, again, like just to show you some other real life examples. So if you've been to Singapore, like there's only one airport, which is called the Changi Airport. So one of the busiest airports in the world. So in this particular project, they're actually constructing a new underground train tunnel at the airport premises. So they install sensors near the airport runway. So this is the actual runway where planes take off and land. So they install sensors to monitor whether the runway is getting impacted because of the tunneling work under the runway. So those sensors were monitored with our system while that project was ongoing. And this is also a very interesting project. This was done in South Africa. So if you ever go to Johannesburg in South Africa, this is like a must visit place. It's called the Sterkfontein Caves, which is essentially called the cradle of humankind. So this is where scientists or historians found the first human fossils, like the first Homo sapien fossils. So this cave is like about a kilometer deep underground. And then because of it's a UNESCO heritage site as well, and because of the historical importance, like one of the companies in South Africa is currently monitoring various parameters because of things like climate change and all, there is a chance that this cave might get impacted and it might collapse. So to prevent that from happening, they have installed a number of sensors within the cave, and those sensors are monitored with our system. So just to summarize what has happened with 𝐲𝐸𝐻. So right now the company is doing about 7 digits, like of that's like basically in the order of millions of dollars of revenue per year. And the company has been growing about 30 to 40% year on year on the revenue side. So we've raised about $10 million of funding through venture capital firms. Scale the team from just the two of us, the two founders, to about 30 people in 5 countries when we're at our peak. Right now, for cost optimization, we have reduced the team, but this used to be the team size back at our peak. Right. So the thing is, what like those numbers and results show is like very fascinating. Like there's been an idea that turned into a product that later got sold in many different countries. There's a big team running behind it. So all that sounds really good. But the thing is, the journey from building this first prototype to a scalable product was like over a period of 8 to 9 years was not easy at all. So this is the first prototype that you see, like that we built. I hand built this, so all the soldering work, this prototyping, everything was done by myself, and my co-founder Mubashir did the firmware coding on this particular laptop. So to take the product from this stage to this stage, it wasn't like a linear process. Like people will talk about the good things, right, that happens. But the reality is there are so many challenges and pitfalls that we had to go through in order to build these products successfully. So that is actually what I wanted to talk about during this presentation, so that you all get like a good experience, or at least some things to think about when you start off your own startups or engineering projects. So what do we mean by a sustainable engineering startup, right? So basically engineering is the cornerstone. So through engineering, we can build a product, but then if that product can't be sold sustainably, there won't be a business around it. Right. So these days, because of advancements in AI, engineering technologies, cloud infrastructure, various frameworks, building a product is not that hard, even hardware. So like the barriers for entry have been reduced quite a lot, because like very recently as well, because of all the advancements in like vibe coding technologies and things like that, right? So the engineering part is no longer difficult. The hard part or the most challenging part is building a business around those engineering products or the technologies. So that is what I wanted to talk about, because these are things that you really can't experience unless and until you go and build a business yourself. So the first thing or the first rule about building a startup is not to build a product. It sounds counterintuitive, I know, but the thing is, first of all, we need to understand and validate the business case before we start building the product. So this is the major reason why a lot of startups fail. So if you look at numbers, typically the rule of thumb is around 90% of the startups that are created would fail. And the major reason behind most of those failures is that the founders didn't validate the business case, meaning they thought like this particular product should exist and this particular product sounds really cool. I'm sure someone will buy it, and then they spend months and years building a product that nobody wants to pay anything for, right? This happens quite like a lot. You'd be surprised because like it's like this thing called the ugly child syndrome, right? So you might have like a very ugly baby, but like in your mind or in your eyes, that's like the best baby, the most beautiful baby that exists in the entire world. But to other people, that's not the case. So businesses are also like that. Like you might build a very beautiful product that you think is really cool and lots of people are going to pay for it. But at the end of the day, there's nobody paying for it. So then the business ultimately dies. So therefore, before you even start to write a single line of code, what you should do is you should build the business case or validate the business case before you do the product development work. So how do you validate a business case, right? So this is the hard part, because as engineers, it's easy for us to sit behind a computer and write code and build a product. But then going and talking to real people is hard for us. That takes us out of our comfort zone, but it is really important we do that. So first of all, before you like start building a product, you need to like sort of zoom out and think like, once this product is built, who is the actual customer? Who is the right person who's going to pay for it? And we have to define this as narrowly as possible. Like, for example, let's say you're building a product, a HR product for companies, right? So you can't just say like my target customer is any company, because every company has HR. That is too broad, and it's not going to help you at the early stages. So we have to narrow it down to a smaller group of potential clients that you think you are going to serve. Like, for example, that HR product, you could say that you're building it for small companies that have less than 50 people and that are in the healthcare sector. Right? And like basically the point is we have to keep narrowing it down to a very small set of clients that you can easily approach and speak with. So this is called the ICP. So essentially, once your ICP is defined, I forget what the I stands for, but C is like customer profile. So essentially, once that is defined, you know who you are building for. Then you need to figure out what problem you are solving. Like what is special about your HR platform that you are trying to build. Like maybe it handles like healthcare related HR matters better that the other existing HR solutions don't cover, right? So there might be HR specific, healthcare specific HR matters, like, I don't know, like shift systems or different kinds of leave systems that other companies like don't really cover for healthcare, right? So that could be your specialization in your HR software that you're building. So again, we need to figure out exactly the problem that we are solving. And then finally, we need to be clear about why they need our solution. So again, in that example, why would a hospital buy your HR product instead of like 550 other HR products that are out there in the market? So this is again something you need clarity on. And finally, there's this notion of painkillers versus vitamins. So you need to be clear whether the solution you're going to build is a painkiller or a vitamin. I'll give you an example, right? Like, let's say you have a massive headache. And would you not take a Panadol to get like relief from that headache? You would, like anyone would, because we don't want to live with headaches. We want to get rid of it as soon as possible. So we'll put Siddha Lepa or like, take Panadol or whatever it is, whatever is required to make that pain go away. But at the same time, vitamins are not something that we really go and take, right? Like, even from our young childhood days, parents and school teachers, everyone would say eat mellung and do like take vitamins, eat fruits and all of that. But again, we don't actively go out and look for them or take vitamins consciously because we don't really need them. So startup products are also like that. So if you're building a vitamin, then the chances of failure are really high because your ultimate clients are probably, can do without your product. It's not a necessity. But if the product you're solving is really a painkiller, that's where the market is. So then there would be people lining up to pay you to get that product because they have a big pain that you are solving for them. So this is essentially these are the criteria that we need to think about, but to validate whether what you are building has a business case. So how do we do this? The best way to get answers to all these questions is not to do market research or ask ChatGPT. You have to really get in front of the customers and speak with them. So it's not easy. So this is the hardest part because essentially you need to like reach out to these customers because you're trying to actually sell a product that doesn't even exist, right? So you need to imagine that the product exists and speak with them to see essentially whether the product that you're building makes sense for them. So to interview these customers, there is a way of asking these questions. I won't go into detail, but it's called the MUM test. So this book is freely available. There are PDFs. If you search for this book title along with file type :PDF in Google, you would be able to find PDF versions of this book. So it's a really interesting book that teaches you on how you can speak with your target customers in a way that gives you the answers that you're looking for. Like, for example, if you go to a hospital, again, same example as before, if you go to a hospital and ask the HR guy, would you what do you think about this nice HR software that I'm building? They would be nice people. They don't want to hurt your feelings. They would say, oh, this looks really nice. I really like it and all. But later, once you try to sell it to them, they are no longer interested. So basically, this book teaches a few techniques about how you can ask the right questions to see whether what you're building is actually applicable or whether it's a painkiller for the particular customer. So, so essentially, I'll give you some examples. So you should never ask whether this product makes sense for you. So rather, again, if you are talking about this HR software, we can ask the HR person in the hospital, what is the HR system that you're currently using? And then they would speak. And then say, what are the challenges or what are the things that you don't like about that solution? And they'll say, okay, I really don't like that software because it doesn't handle shifts properly. And then you can ask a question like, oh, that's interesting. It doesn't handle shifts. Like, what else have you tried to solve that problem? And then they'll say, oh, because my HR software doesn't handle shifts, I'm maintaining my shift allocations in Excel and it's very manual. It takes me 5 hours to do that every day. And then another question could be, oh, if it's taking you 5 hours, then does that mean you have less time for the other things that you need to do? And then the HR person say, yeah, that like they really stresses me a lot because now 5 hours is spent on making shifts and I have less work to complete my day-to-day HR responsibilities. So I often have to work late hours and then file for overtime, right? Like things like that. So now basically by this line of questioning, you've tried to understand their pain point and what they have tried before to see exactly whether what you're thinking of makes sense for them. So that is the way that you should question like potential clients to understand like what is the problem that you're solving and whether what you are build like planning to build makes sense for them, and whether it's a painkiller or a vitamin for them. So once that those questions have been answered and you have clear results, then it's easy to validate what you are going to build. So the best form of validation for the business case actually comes from having paying clients even before you build. So you might be surprised, actually, this is achievable. Even for ThermoTune, this was the case. So we managed to get our first client to pay us before we even had a product. We only had a PowerPoint deck. So the customer really liked the idea of what we are doing, and it was solving a big problem for them. So they paid us for they prepaid for the product so that we have some cash that we can use to build the product. So this is the best form of validation that any startup could get, and this is what you should try to aim to achieve. The second thing is, if you don't have like those kind of paying customers, you can try to get a LOIs or letter of intents. So you can again talk to the hospital and say, hey, like I'm planning on building this new HR software that handles shifts. So it can help you get back 5 hours of your day. Would you be interested in trying it out when we are ready to launch? And they'd say, oh yeah, that sounds really interesting. I'd be happy to help you build it as well. And then you might be able to get an LOI signed from them saying that once the product is ready, they would be willing to test it. And then thirdly, like some clients would help you build a solution by providing you with data and real life like scenarios that you might not have access to. So when they get actively involved with you like this to help you build the product, that's the best form of getting validated. Okay, so that's the validation part. That's the first challenge. I'll move on. If you guys have any questions, feel free to drop it in the chat, or we can take them later as well. So let's move on to the next challenge, which is essentially about scaling the product from a prototype and doing testing and then scaling it across like multiple different clients. So I'll talk about this from Axios context and we'll talk about some mistakes that we have made. But these lessons apply to any business, I would say. So the first thing that we got wrong was we didn't do enough iterations of the product. So meaning like because this is a hardware problem, a hardware product, it was even more expensive because every time we had to make a revision, we had to make the PCBs and like do the soldering work, everything all over again. Of course, for software, iterations are much easy because you can change the code, recompile and redeploy, and you have the new product. So, however, we still need to iterate on the product very fast. Meaning, again, taking the same hospital example, like you should not wait until you have built a very nice polished product and give it to the customer, because their requirements, you won't be able to capture all their pain points and requirements until they start using the system and give you feedback. So if you take like 1 year to build the product and launch it, and then the customer you're building it for like says 50% of the product is not useful or is not exactly how they want it to be, then you have to spend another good like 2 or 3 months maybe rebuilding the product. So rather, the right way to go about it is we build in quick iterations, meaning we build like a mock-up using Figma or something, a clickable prototype. Then we go and sit with the hospital person and ask them to use the prototype and see what feedback they have. They might say, oh no, this screen doesn't work. I don't need to enter these fields. These are already there. Like, they'll give lots of different feedback. So it's always easy for people to give feedback when there's a real tangible thing in front of them. So once the Figma feedback is received, you can go back, build up another Figma prototype based on the feedback, and then put it in front of go and meet the same customer again and ask them to give feedback. So then they'll utilize this and say, oh wow, okay, now this is like almost there. I can't wait to test it, or something like that, right? And then you go and code it up and have one, like a version 1 ready, give it to them, and again get feedback. So you have to keep doing this over and over again to perfect the product. So that's the correct way of building a product. Like, rather than having like one massive big release which might not work, you do small but very fast iterations of the product and keep refining it with the feedback that you're getting from the customers, so that you can improve it every single week or every single day even. So this is like really important. You need to iterate quickly and fast with feedback from the customer to improve the product. So the second thing that we didn't do properly is essentially testing work. So because we didn't test out the product well enough, we had to do like often more sites visits. So this is actually one couple of our engineers visiting these actual construction sites, because things didn't work in the site, although they worked inside the lab. So this happens with every single product. So once you build something, test it test it and make sure that there are fail-safe modes and things like that added, so that once the customer is using it, they get a good experience, right? So that is quite important. And thirdly, another mistake similar connected to testing is we didn't test it in real life scenarios. Meaning, although we did like lab testing and in like small pilot sites tests, we didn't test it in enough of like different settings, enough different sites, so that we could capture lots of different failure cases. So again, I'll give you an example. So this is a picture of one of the devices that we produce, and we shipped it. Like, we found a new client in Taiwan, and they ordered 2 of these devices to test out. So then in Singapore, we tested everything and shipped it through DHL to the client. And then the client said they tried to use it, but it's not working. Like, they couldn't even turn it on. So that was very surprising, because we actually tested it before we shipped it out. So we said, okay, don't worry, we'll send you a new one because it's covered under warranty and all. So we again, this time around in Singapore, we did like lots of different tests. We ran it for a week to make sure that it's working properly, and again shipped it to Taiwan. So once they received the devices, again 1 day later, they call us and inform, hey, the second one is also not working. I don't know what's going on. Your products don't seem to be very reliable. So we were quite surprised by that comment, right? Because second time around, we tested it for a week and made sure everything is working before we shipped out. So then we said, okay, hold on, we'll send you another device, but this, like, don't turn this on until let's do a video call, and then we want to see what's happening when you guys test it, because we were worried that they might be doing something incorrectly that damages the device, and then they end up complaining that it's not working. So the third device, again, we tested it extensively in Singapore, shipped it to the client, and then we held a Zoom call and connected them through a video call to see what's happening. So then we had the entire engineering team looking, like very diligently into the computer screen to see what's happening in Taiwan. And then one of our engineers actually caught what was happening. The problem was when they put the battery into the socket, like as what you see in the picture, there was an electrostatic discharge. So you might have seen this happening, especially in colder countries, or if you're going to dry environments. If you touch a metal interface, sometimes there's like a sudden spark that sort of, like, like you sort of feel like you got electrocuted. So that was happening because their meeting room is quite dry. The air condition is quite dry, so the humidity is quite low. So when they put the battery, the finger that is like when it touches this metal piece to enter the battery, it creates an electrostatic discharge, which was burning the entire circuit. So that's when we realized that our circuit design is fundamentally flawed, because it is highly sensitive to electrostatic discharges. So meaning we can't sell our products in any cold country or any place where the humidity is low. So, and we had not even thought about those kind of like scenarios until this failure happened. So this is again an example to show why testing is important. So especially again, going back to the same hospital example, if you are going to deploy it in a hospital setting, try to find 5 other hospitals that are similar and try to do testing to ensure that the solution works in all different kinds of hospitals, in different kinds of like environments, to make sure all those requirements and like corner cases have been handled properly, right? Otherwise, you won't be able to scale the product. So talking about scaling, that's the third challenge that I have listed here. How do you scale the business, right? So building a prototype or the first version of the product is easy. How do you sort of sell this product across like a wider set of clients, build a team and build a successful business? So to get the product sold successfully, so to get the product sold successfully, you need to build a robust GTM strategy. GTM stands for go to market. So essentially, that's nothing but thinking about how do you sell this technology as fast as possible, like without you having to go and sell it to everybody, right? So this is comes in the form of sales channels. So essentially, how do you sell your HR software to hospitals? You can hire a sales team, right? So that's called selling direct. You might put regional salespeople in Colombo, in Gaul, in Kandy, in Jaffna, in Trinco, or whatever it is, right? So you basically clone yourself by having more people as sales reps that can go and sell this technology into hospitals or like wherever you want to sell it. The other way is distributors. Like you won't be able to hire people all around the world, which is very expensive. So you might partner with distributors, like let's say companies like SoftLogic, for example, in Sri Lanka, like we can find those kind of like technology distributors in different countries and try to have partnerships with them and use them as your sales channels. And then you can do partnerships. Like, for example, let's say hospitals are buying a certain finance solution or an accountant solution. You partner with them and like have a partnership agreement where the finance company, whenever they sell their accounting software, they provide your software as an add-on, or the other way around. When you sell your HR software, you can take the finance software and like have sort of a mutual cross-selling kind of opportunities. So those are called partnerships, right? So essentially the idea is you need to think about how do you go from you doing all the sales to a scalable model that can be used to duplicate these sales efforts across multiple different clients and regions at the same time, because you can't do it yourself. So that is called building a GTM strategy. So then the thing is, after that, again, when the team is small, it's easy to manage because it might be just the two or three founders, a few team members. So it's like one small happy family. But then that small family or the small team can't scale the product or a company. So then the team has to grow when the business is becoming more successful. So then building this team and making sure everyone is working towards a common goal is actually hard. So especially with Axio, like I'll give an example. So when the team was very small, we used to do a daily scrum. So everyone, like when you were like even 10 people, we had this morning 10-15 minute scrum. So we had the engineering people, marketing, HR, all these people talking about what are they going to do for the day in this quick 10-minute sync up before we started work. But when the team grew to about like 15-20 people, we couldn't do that because the updates are not really relevant and people were wasting time just by doing that. So then we had to restructure how we do the daily scrums in a way that's meaningful for the companies. And then like other cultural things, like, when we were small, we used to celebrate everyone's birthdays. We used to buy a birthday cake, sing happy birthday and do that. But then when we have like 20-30 people, having a cake for everyone's birthday is not really practical. So then we used to do like monthly birth celebrations. So things like that. So you need to figure out when the team grows, how like there would be things that break. So we need to figure out how to solve those things so that you can again keep the team motivated to do their best work at the office and also work towards a common goal. So again, there would be scaling challenges in managing large teams. So then finances, this is very important. So again, the companies live and die on cash flow, right? So which is essentially the lifeblood of any company. So you need to have very strict process on how you manage your company's expenses, the financial health, the profit and loss, balance sheet, and income statements, and all these financial documents. So I had no financial background at all when I started Axios. So these are things that I learned myself in order to manage it as best as I can, so that when we had like investors investing into us, we could give them credible numbers on the company's financial health and the projections. So this is something that as engineers, we are not very good at, but we need to pick up as well. And finally, pricing. So we need to, like, at the beginning, you might like just do free pilots or give like sell for very low prices. But then as the company scales, you can't keep doing that. So you need to think about your profit margins, your unit economics, like really CAC stands for customer acquisition cost, CLV stands for customer lifetime value. These two parameters are very important. So the first one says how much money are you spending to acquire one client, and CLV is how much value are they giving you once you've acquired. Like let's say you spend $1 to acquire a customer, and that customer once buys only 50 cents of things from you, you're basically making a loss for every single customer you onboard. So that's not a very good business. But let's say you pay $1 to acquire a customer, but the customer pays you $5 for the product. That's a really good business, because for every dollar you spend, you are getting 4x revenue. So that is something that you can multiply and turn into a successful business. All right. So these are like few things that I listed that I had to learn, and again, my team as well. Like I had to spend quite a lot of effort on in perfecting. I wouldn't call it perfecting, but at least like improving, so that the company can scale beyond like a two-founder or an early stage product into something that's more large scale. So 3 pieces of advice. This is the last slide actually. So this is the first one. This is the most important thing, because as I said, a lot of companies die because of this situation. So go and talk to potential customers, validate the business before you build. It's really, really important. So I would challenge you not to even write like a single line of code until this is done. And then once the validation is complete, iterate fast. So build like the leanest product possible, give it to the customer and get them to test, get feedback and improve. And you keep doing that until the product gets polished. And then finally, like scale when the time is right. So once you see the product is getting adopted and the customers are quite happy using it, for example, in that healthcare the HR example, let's say you've been selling to about 10 different hospitals and all of them are happy. You are seeing like lots of more customers lining up. Then you can figure out how you can take this maybe to India, the next closest market, right? Or like to, I don't know, to Singapore or any other country where you want to sell it. So scaling has to be done strategically. So you can't just build an MVP and then try to scale it. It doesn't work like that. So yeah, I think these are some 3 big pieces of advice or experiences that I wanted to share with you, so that when you start your own entrepreneurship startup journeys, hopefully these things would help you. Yeah, and with that, I would like to wrap up and see whether you guys have any questions. That's it.
Okay, so can you hear me, sir? I'm Anupama.
Yes, Anupama.
So I have one question that you have mentioned. So in the early stage of the startup, building a trust is quite challenging, no? So what strategies would you recommend to gain customer trust early on? And how did you build the trust when you started your own business? And also when we are finding an investor or like that, it's also difficult to get this trust on our business startups.
Yeah, no, good question. So the trust, it's not automatic, definitely, right? So I mean, of course, if you know the person previously, then it's a different story. But assume you have no experience or no prior background with this particular customer or the investor. So I'll talk about customers first. So the best way of establishing trust is by working with them closely. So that's why I said even like from the validation part, that's when you get connected. But over time, when they see that you're really putting in time and effort to understand their pains and like coming up with a product that solves their pain, they start trusting you. So that's the process that we went through as well. I'll talk about ThermoTune because that's like a more recent example. So the first paying customer we had, as I said, like paid us before we even have the product. So that didn't happen on day one. So day one, we reached out to the factory saying, like we are a company based in Singapore. We are solving this problem. We would love to come and speak with you to understand your process, right? We didn't even say we want to do a demonstration. We said we want to understand your operations. So we went to the factory and met with the managers, the people on the site. We didn't pitch, we didn't provide like demos, or we didn't talk about the solution. We just asked them questions like, how are you managing your production planning? How are you running your boiler? What is your fuel bill like? Things like that. So we really understood their problems. So then we came back, analyzed the data, and then went there again and said, okay, this is what we learned from the first visit. These are the kind of challenges that you have, and these are the areas that we think we can help you improve. Would you like to collaborate and do this project together? Right? And then so then at that time they said, yeah, this sounds really interesting. And they asked us to provide more details about how the solution works. And then we did another visit where we showed them exactly how our solution has been designed to solve those challenges we observed in the first and second meetings. So that builds trust, that builds credibility, because you're demonstrating that you're understanding their pains and you're solving that. So when that happens, that is when trust is slowly established, and then you guys, become business partners and work together. So that's the way to go about it, Anupama. But essentially, it doesn't happen on day one. You need to go and meet them, speak with them, understand them, show that you really care about their problems, and you're trying your best to solve it. So then it establishes the trust. With VCs also, it's the same thing. Again, like VC decisions don't happen on day one. It's again, you might first meeting, you might go and pitch about what you're doing, and then you will have to keep them updated about your progress and over time for a few months at least, so that they know they can trust you, that you are being transparent about both the good and bad things that are happening. Because that's how investors start building that trust with you. So yeah, it's all like a lot of, so this is the non-engineering part, which is like more challenging for us engineers, because we are not accustomed to going and speaking with people, sharing information, getting feedback and things like that. So, but it is quite important in order to build trust. Yes.
Right. Thank you very much, sir.
No problem.
Actually, I have another question regarding of that. So when developing your product before entering the market, so how important is to get obtain certification early on, like that, some certification to talk for the product too, like that. So, and also what stage should the startup focus on getting them?
Sure. So again, it's a very relevant question for Axio as well, because we were selling wireless devices. We had to get CE, FCC kind of like certifications, but we didn't get them right at the beginning because the products were early stage. So what, like in most countries for POC kind of like deployments, proof of concept deployments, usually you can get away without certifications. So this is where you need to get creative, like figuring out how best you can sort of like maybe even read between the lines and see how you can get the product like operable basically without going for certifications. So I'm not saying you should do that indefinitely. I'm saying you should try to avoid doing certifications at the beginning because you are still maybe trying to validate, you might be still iterating on the product. So you might not have the right product that you require for certifications. And the certification process typically are expensive. And once done, again, it might cost you a few $1,000s. But let's say next month you figure out that your like design doesn't work and you need to change it. Then you need to go and recertify, which is like an extra expense. So that's why the correct strategy would be to figure out how exactly, either through like trial arrangements or non-commercial agreements, like yeah, there's like different creative ways of going about it to like basically try to like validate that the product works and that you have built it to a certain level before you go for certifications.
All right.
And yeah, that's exactly what we did with Axio. Like the first few devices, we even shipped it out to countries saying that these are demo devices, not for commercial sale and things like that, so that the customers could test it and give feedback before we eventually certified everything.
Thank you.
Yeah, no problem. Good questions. Thanks. Anything else from the people?
So I have another one question, sir.
Sure.
So can you explain again for like how to convert the idea to a business model? Can you explain again as example wise? So business
Sure.
model.
Okay, sorry, like which part are you referring to? Like essentially taking an idea and validating it is like what I talked about, and then like coming up with a business model for it is a completely different topic. So are you referring to that part? Like how do we figure out how to price it and things like that?
Yeah,
Or the
also as engineers, we know the make a product like something. So, but we have much more knowledge about to convert the business model or something. So, in the early stage, how we think and how we start to make that.
Yeah, sure. So once I think what I said is very true. So we, as engineers, we are good at building the product. So that's why I touched on the validation part, which you should do even before you build to make sure that the product you build is valuable and there's a business case for it. Then the second thing is once the product is built, how do you sell it? How much do you charge for it? So there are a few frameworks, but the one that I like the most is called the rule of thirds. So essentially, you need to figure out like with your product, the value that you are giving to the customer. So let's say that, and usually there are three types of values. So either your product would increase their revenue, reduce their costs, or make them more productive. So these are the three reasons why anyone would pay for something, right? Just think about it. Why would anyone pay for ChatGPT? Because it's making them more productive. It reduces the time they spend doing things manually. So people pay for it. Okay, so what is another example for revenue? Nothing comes to mind right now, but again, you like a company might pay for a certain product because by using that product they get extra revenue, like for example HubSpot. So a lot of companies pay for things like HubSpot or Salesforce because it helps them manage their leads, send more automated marketing, emails and things like that. That gets them more leads and therefore more customers and increases their revenue, right? So that's the revenue increase. Then the third is cost decrease. So maybe by like especially AI now, right? With Cursor or with Claude Code, we don't need as many developers as we used to before. So you would pay for that tool and get like extra capabilities so that you can reduce your development costs. So that is an example for cost reduction. So these are the three reasons, like revenue increase, cost decrease, productivity increase. These are the three reasons why someone would pay for a product. And then what you need to understand, because of your product, how much in terms of dollars and cents are they getting in terms of value? Like, let's say because of your product, they are getting $3,000 of value, $3,000 of revenue increase, $3,000 of cost decrease, or $3,000 worth of productivity increase. So then the ideal sweet spot is to charge them 1/3 of that value. Like, so if you are giving them $3,000 extra revenue, you charge them $1,000, 1/3, as your fee, and they get to keep $2,000 of that revenue. So that is what I was meaning. Like, essentially, you try to understand which value you are providing, quantify that value, and try to see whether you can get 1/3 of it. Of course, that is like not the only criteria. Then you need to look at your costs as well to see what your gross margins are, to make sure that the gross margins are healthy, and then basically you can fine tune it. So that would be a very simple way to start as a starting point, Anupam, and then you can optimize it from there.
All right. Thank you very much.
No problem. Anything else?
Guys, any questions?
Hi, sir. Pradeep here. Good
Yeah,
evening.
Pradeep. Good evening.
Sir, so I recently completed an internship at a pharma company, sir. So one of the problems I saw in the solar is like accumulating of wet dust that reduces the PV efficiency. So my initial thought of this is for my final year project idea. I was thinking of an automated dust detection and a remediation system for solar rooftop PV arrays, especially in tropical countries like Sri Lanka. So from what I have researched, like by reading literature, research articles and others, so PV efficiency, so dust, bird droppings and others, like reduce the efficiency by around 15% in general.
Okay.
So I was planning to create a product or a prototype, a mini prototype, like considering like using LDRs to determine the light transmission and current and voltage sensors to detect power, humidity sensors to detect whether it's like wet or dry, and developing a fuzzy logic and implementing AI detection as well. So like this is my initial thought, like what factors do I need to consider if I need to take it to the next level, like for a product?
Sure. So again, validation. So first of all, like, I think the idea sounds really cool, but before you start spending any time on it, like building up the product, go and speak with companies that deploy solar panels. Like, again, I'm not very familiar with the solar market in Sri Lanka, but like, let's say, I don't know, Richard Peary's or find companies that are deploying this as a business, and then go and speak with them and ask them questions about this particular problem and see how much of a problem it is to them. Are they really seeing a drop, or is that drop not like negligible for them, or is it something that they really care about? So when you speak with them, you'd be able to understand whether this thing makes sense. Especially for hardware startup, this is something that I would really advise or suggest, because building the product, as you correctly said, is expensive. You need to invest in this like sensor modules. You need to figure out how to like productize it. And it's hard to iterate. Hardware products takes way longer to iterate and very costly as well. So do the validation first. Make sure that there would be customers who are ready to even pay for it, maybe to do like a POC with you, so that you can do like a joint product development kind of a thing before you even start thinking of building the product. So once it is built, of course, then the same things that we talked about apply. Try to come up with a very basic product with like simple sensors, and see how you, with the technology that you're thinking of, is scalable, can it even solve the problem. So once those things are validated, then you can think about how to like improve the product and productize it even a better way. So it's a good example of what we were just discussing. So that entire flow applies to you as well, Pradeep.
Thank you very much.
Yeah. Okay, if there's nothing else, then we can start. It's 11 in the night here. Yeah, if there's any other questions, please feel free to I think you guys can find me on LinkedIn. I check my LinkedIn quite frequently, so that's the best way to reach me. Yeah, so if you have any questions or want to discuss anything, reach out anytime. I'd be happy to see how I can support you guys.
Hasin Rangi, can you continue?
Thank you, sir, for your valuable session, which I'm sure provided all our attendees with unparalleled advice and insights. And I also thank you, sir, for taking the time to share your knowledge and expertise with us. I would like to hand over the session to Chairman IET on campus NSBM, Green University, Mr. Anupama Nethma. Over to you, Mr. Anupama.
Right, thank you, Hasini. Actually, good evening, everyone. So it's a great pleasure for me as the chairman of IT on campus NSBM to deliver the vote of thanks for today's insightful session on engineering solution into sustainable business. So first, I would like to extend our sincere appreciations to Dr. Nimantha Baranasuriya for sharing his valuable knowledge and experience with us. So your session has truly inspired us to look beyond technical knowledge and think about how we can create real impact through the sustainable and innovative solutions. So I would also like to express my gratitude to Engineer Lasitha Balusuri also for taking the initiative to connect us with such an inspiring speaker. So your support means a lot to us, and we truly appreciate your effort in helping us grow. And especially thanks go to our MSc also, Ms. 𝐍𝐒𝐻𝐿𝐴𝐻𝐿, for her continuous guidance and encouragement, which always motivates us to achieve more. And also, I would also like to thank the IET on campus NSBM team for their commitment and hard work in organizing the successful session. And finally, I would like to thank all the participants for your time, attention, and active involvement. With that, I conclude. Thank you, everyone.
Thank you, Mr. Anupama. Before we conclude, we would like to capture this moment. We kindly invite all participants to turn on your cameras so we can take a quick group screenshot.
Sure. Thank you very much, all.
Finally, thank you to each and every one of you for your participation and for making this event a great success. Thank you.
Thank you, everyone. All right, take care.
Bye.
Thank you. Bye.
Thank you, sir.